Welcome back, everyone. Believe it or not, we are already at the end of this unit. So this is going to be the last lesson on circle properties. Next week, we're going to be doing something different. So this is kind of where we're going to start tying it all together, but we also have a couple more things to talk about first. So first of all, is if you have 2 points that are exactly opposite of each other, like A and B here, then you could draw half of a circle on the top, and you could draw the other half of the circle on the bottom. Doesn't always work like that. In fact, that's pretty much never going to happen. What's usually going to happen is you are going to have 2 points that aren't exactly opposite. So maybe I give you something like this, and maybe I tell you something about this angle right here. If we want to talk about this top part of the circle, we are going to call that the major arc. So it's an arc because if you were to literally just look at the shape that I just drew, that looks like an arc. We call it major because it's bigger. Bigger than, oops. Hold on a sec. Bigger than the one on the bottom, which we will call the minor arc. So again, arc because it's shaped like an arc, minor because it is smaller. Where those two lines, so again, we're thinking back to the ones I just drew, where those meet up, if it's in the very middle, middle is like center. So we can call this the central angle. Central meaning middle. If for some reason I drew 2 lines that crossed up over here, this is not a central angle, and none of the rules we're about to talk about will apply. Only central if it goes through the center of the circle. If we want to talk about, so maybe they do not cross over in the center, but they cross over on the edge of the circle, word we use for that is inscribed. So inscribed kind of sounds like inside. This is still inside of that circle, but it is not in the center. So again, let's go back to the counter example I used before. This is not an inscribed angle. That's not a central angle. This is not something we can do anything with. This, if it lands on the edge of the circle, that is something we can work with. We call it inscribed. Some more vocab. If we have a central angle and we want to talk about the arc that connects the 2 points from which the lines come that make the central angle, we can call it a subtended arc. So this could be referred to like this right here. We could say minor arc. We could also call it subtended, and then that tells us we're talking about this angle right here. If we wanted to talk about the major arc, that would be this arc right here, which would then tell us about this angle right here. Normally, though, we're going to work with the minor arc, and we can use the word subtended for that. So, all of those are subtended arcs. We have this example over here, kind of summarizes the last few slides. If we have point A and point B, and they meet up in the center of the circle, we call it the central angle. If they meet up on the edge of the circle, we call that an inscribed angle. And if we want to talk about the line around the circle that would connect these, we call that the subtended arc. So interesting thing about central angles and inscribed angles is that the central angle is always double what the inscribed angle is. So what that means is that if this inscribed angle, let's say that is 40 degrees, that means that this central angle will be 80. And the cool thing about this is that it doesn't matter where that inscribed angle is. Let's say we drew it over here. If this is 40, this will still be 80. And we can draw it over here as well. If that's 40, this one will still be 80. Doesn't matter where you draw it, it always ends up that the inscribed angle is half of the central angle. So, a couple more examples there. 71 times 2 would be 142. On the previous one, 47 times 2 would be 94. That angle is always, the inscribed angle will always be half of the central angle. Which means that if you draw a whole bunch of different inscribed angles, they're all going to be equal. And now we can use this with some more complicated questions. Like if we're looking at something like this, when I'm asking you to solve for x and y, well, we can look at this and we can see y is inscribed by lines that come from, let's call this point number 1, and by a line that comes from point number 2. So y is inscribed by points 1 and 2. X is inscribed by point 1 and by point 2. Therefore, x and y have to be the same angle. And we can use this rule for all kinds of questions like this where we're asked to figure a bunch of things out. While we're here, we can actually say what x and y are. Because this central angle is also inscribed by point 1 and by point 2, which means 116 has to be double what y and x are. So if I go 116 divide by 2, I can tell you that y is 58 degrees, x is also 58 degrees. So that's kind of what this picture right here is showing you, is that all of your inscribed angles will be the same. Other cool thing is that if they do happen to be exactly across the circle from each other, so we're looking at like A and B here, go exactly through the center of the circle, this will always be 90 degrees. No matter where you put it, you could put it right here, you could put it here, it'll always be exactly 90. This actually follows the rule that your inscribed angle is half of your central angle. Because when we have a straight line like this, really what that's saying is you have an angle of 180 degrees. Half of 180 gives you the 90. So this is kind of a special case, but it follows the same rule. Let's look at, so we already did this one. Let's look at this example right here. Not going through the center of the circle. So that should tell you we can't use a bunch of the rules that we've used before. Like previously we had said, okay, this is a chord right here. Anytime something crosses a chord, we were drawing a 90-degree angle. But we only got to do that if the chord that went through it also went through the center. And this one doesn't do that, so we're not going to be able to use that rule. What we can do is we can say, okay, this angle right here, I know something about that. It's 52 degrees. I also know that it's inscribed by, let's call this point 1, and let's call that point 2. I can see somewhere else that is inscribed by those 2 points, which means that x has to be the same thing as 52. So x equals 52 degrees. And that's what's going to help me get the rest of this question going. Because if you don't see that, you're going to struggle to get going on this one. After that, I'm going to look at this triangle right here. And I'm going to say triangles have to add up to 180. Which means this is 52, this is 28. Z has to be everything else to get up to 180 degrees. So if I subtract out the 52 and the 28, that will give me what Z is. So Z should equal 100 degrees. So where we're at now is we have, that's 52, that's 100, and we're still trying to find Y. I can't quite do the same thing on this triangle because I only know one of these. And I can't just guess that that's going to be a right angle because, again, the rule that we were using before, we know that one doesn't work out. And this, like, it looks pretty close to 90, but it's probably not exactly 90. What I can say is that I have two lines crossing over each other. And anytime that you have that, it works out that this angle is exactly the same as this angle, and it works out that this angle is exactly the same as that angle. So I know what this one is. That means this one has to be 100 degrees. Think back to when you learned about transversals. These are what we call opposite angles, which means they are the same. Now, I can say my triangle adds up to 180, subtract out 100, subtract out 52. I can say Y equals 28 degrees. Okay, let's say that you were feeling really stuck on this one because you didn't realize at the very start that this angle, was inscribed by these 2 points, and this angle was inscribed by these 2 points. Let's say you didn't see that. How else could you start this question? Well, I can see this 28 degrees right here. That is inscribed by this point and by this point. And another point inscribed by those two lines is this Y right here. So you could have looked at this one and said, okay, if this is 28, this also has to be 28. And then you could have worked the whole question backwards. You could have gone from there, 180 minus 52 minus 28 equals 100. So you could have put 100 right there. And then you could have said, okay, this is 100 as well. And then you could have done your other triangle. There will sometimes be more than one starting place with questions like these. So just keep, like, if you are feeling stuck, keep looking at it. There's going to be somewhere for sure that you can get going. What I'm going to do now, because this was a relatively short unit, I'm going to put a check-in for these 3 questions right here. So this is slide 37. The check-in will say, look at the picture on slide 37. I can't actually put this picture into the Google form or else it goes all crazy. So slide 37, that is this one with water in a pipe. Slide 38, that is this picture right here. Google form will say, refer to the picture on slide 38. And then slide 39, that is this one.